graphically, and would you write the word numerically right here? Okay, so we're going to kind of look at the algebra behind this just a little bit. Graphically, kind of display what's going on, and then we're going to kind of think about, hey, what happens with this numerically? So on that one, on the first warm-up here, it says use your calculator to find the sum. So yesterday we were looking at this, and I said you can do it a couple different ways. And when I was talking to Miss Doty, we actually found another way to do this. So I want to make sure we need to know how to do it each one of these ways, because some parts on the calculator don't have that nice little menu. So yesterday, Mason said, hey, you can just put this in by hitting what, Mason? What was your idea?
You can do math 0.
Okay, so hold on a second. If you hit math and then hit the up arrow, you'll see that it has a summation thing right there. Now, if you have a nice operating system, if you have an updated operating system on the calculator that you use on a regular basis, if you hit math and 0 or just arrow to it and then hit enter, you'll get something like this, okay? And it'll let you choose what the index is. So in this case, it's an n. You could go to the trouble of writing an n using alpha and stuff like that, but let's just go ahead and make it x. And we're going to do x and 1 and 5, and then we're going to do a 3, parentheses, and then the fraction, okay? We got the 2 over 5. Parentheses here. Oh, because it closes in the parentheses for you. Okay. There we go. There we go. Okay, hop all the way on the outside. Hit enter, and there we go. There's the answer in fraction form. Okay. So 61, 86, 31, 25. You could change that to a decimal if you wanted to. We do need to know the other way to do it. So I'm going to hit second stat. We're going to do some math. Okay, and we're going to do number 5. We're going to do the sum. And then we do stat. We're going to do ops. Number 5 is a sequence. And depending on your operating system, it will have this information and you can just fill it in. Other times it will just go back to the home screen and you have to type things. So we want to type in the expression. So I'm going to delete all that stuff. And I'm going to type in a 3 and then parentheses. And I wonder if it will let me do this here. It does not. So we're going to do 2 divided by 5. And we're going to raise that to the x. The variable's x. We're going to start at 1. And then we're going to go to 5. And the step is always going to be 1. And we're going to paste that. Okay, so it'll make it look like this.
Wait, how do you get to there?
Okay. You hit second and stat. It's the list menu. Okay. Did we get it? Okay. Hit enter. It gives us that. We're going to hit math, have it change it to a fraction. And it gives us exactly the same answer. Okay. There is one other way that you can get there, and you can get to that summation a different way. And that is to hit alpha and hit the window button. And if you notice that number 2 there, so this takes an extra keystroke, but it'll get the same thing on there. Okay. Either one is fine. Different settings will call for different things. So on this one right here, it says write this one using sigma notation. This does not require a calculator. So I'm going to go full screen on this one. You are going to need to be able to do this on a test, so make sure you're ready for this. Let's see, I'm going to ask Wilson. Wilson, arithmetic or geometric? Arithmetic. Okay, can you tell us why it's arithmetic?
Because it changes by the same interval.
Okay, and so it has a difference. What's the difference on this one?
3.
So what kind of 3?
Negative.
A negative 3 because it's going down. So we need to write down the formula for this. So the nth term formula is going to be the first one, which is 7, plus n minus 1 common differences of 3. And just make sure you distribute through the right way. So this is going to be 7 minus 3n. That's going to be plus 3. So we get negative 3n plus 10. There's our formula. Whoops, that looks horrible.
What if you did?
Hang on. So we're going to go k equals 1. So we're going to do negative 3k plus 10. And then what term is that? How do we figure that out? Wilson?
Never mind.
Okay. How do we figure that out? Luke?
I guessed and checked.
You can guess and check, but if it was a gigantic number, you probably wouldn't want to do that. Crew?
I just like plugged it in.
Yeah. You set it equal to 7, and then you solve that. So if we move this, sorry, 17, negative 17. So if we set that equal to negative 17, move that over. That's a negative 27, divide by negative 3. Everybody agree that this is the 9th one in the
I
series?
guess.
Okay. All right. Any questions there?
No.
We're good?
Yeah.
Okay, so here's what we're going to do. Okay, when we find the sum of a couple of terms in a series, we call that a partial sum. You might have noticed that that phrase showed up in the assignment yesterday, so we call that a partial sum. And we label each partial sum with subscripts. And we can use the information by exploring things with partial sums to kind of make some conjectures about what is an infinite sum or what would an infinite sum be. Does anybody know another word for the word conjecture?
Yes.
That's it. Okay? A conjecture is just a guess. So all we're going to do now today is we're going to do a couple problems where we just explore and say, hey, what do we think would happen if we let this go on forever? So we continue adding and adding and adding and adding. And believe it or not, you can continue adding forever. And sometimes we get an answer. Fancy word for that is we say the answer converges. And then sometimes we don't get an answer, and the fancy word for that is diverges. But we won't use that vocabulary here. So we're going to run through and we're going to do these things on each problem. We're going to do 2 in class, and then you've got a couple problems on your assignment. So it says, find the first 5 partial sums, organize the information from the partial sums into a table, make a conjecture, in other words, make a guess about the value of the partial sums are approaching if the pattern did continue, use a graphing calculator to graph the series, okay, and there's some step-by-step instructions on the next page, and does the graph confirm your conjecture about if the series were infinite, what the sum is. So we're going to do this one right here. So I'm going to shrink this down and we're going to use the calculator, and we're going to hope that we can do this correctly. So I'm going to clear this off, and so I don't have to type this in and hit this stylus over and over again. I'm going to grab this one, okay, and we're going to come back here, come all the way through here, and the first partial sum is what we get when we just do the first one, okay. Now, that wouldn't be too bad. You could figure this out by hand. So this is what we're doing. We're doing 3 and then 2/5 raised to the first. So I'm hoping that works. Yep, 6/5, which is about 1.2 if we use a decimal for that. So again, you could do it by hand, but I'm guessing most people want to do this on the calculator. So we want to add those together. We want to add together the first 2. So that's going to be 42/25, which we're going to change to a decimal. So this is going to be 42/25. So as a decimal, whoops, I want the other one. 1.68. So we're going to go, this is called the third partial sum, and we get 234 over 125, and we're going to change that into a decimal. 1.872. Okay, so there's the third one. There's S3, we're on S4. So the fourth partial sum. So just to make sure we're clear on this, what we're doing is we're adding up the first 4 terms of this series. We're just having the calculator do it for us. So 1218 over 625, and as a decimal, 1.9488. And then we'll do the last one. So let's see, 6186 over 3125. Certainly wouldn't want to do that by hand. Change that to a decimal. 1.97952. Yeah.
Why are we turning it into a decimal?
You'll see why. Okay. So the first partial sum is 1.2. The second partial sum is 1.68. The next one, we're going to run out of room shortly, so we'll call this 1.87. Then 1.94 is the fourth partial sum, and then we'll call this 1.98 is the fifth partial sum. So, what's our conjecture? What's our guess? If this pattern went on forever, if we did the sixth partial sum, the 600th partial sum, the 6,000th partial sum, so added up 6,000 of these numbers, what do we think we'd get? Yeah. What do you think the answer would be? Are these tending to some number? Zach?
Exponentially towards 2, so it's going to get ever so slightly closer to 2.
Ooh, I like that. Ever so slightly closer to 2. So your conjecture is the answer is going to be, if this went on forever, if this pattern went on forever, the sum that we'd get would be 2. Is that right? Okay. Everybody good with that? So there's our guess.
Like, you had to add all of them together.
No, so just to be clear, here's what's happening on this. To get this first one, we had one term. The second partial sum, so this is S sub 1, this is S sub 2. We added the first 2 terms. We added the first 3 terms, the first 4 terms, the first 5 terms, and so forth. So if I said S sub 600, that means you'd add the first 600 terms of that series.
Let's try.
And you'd tell it what it is. Okay?
Oh.
So here's, yeah, Samara.
Oh, I was just wondering, why did we round up the fifth one and not the fourth one?
Because that one was a 9. I take that back. That should have been a 9.5.
Silly
I looked at the 4. Yep, thanks. Okay, flip over on the back side.
What back so?
Oh, no. Yeah.
Still going.
Okay. So here's what we're going to do. We're going to we said we were going to kind of explore this algebraically, graphically, and numerically. We just looked at it numerically. Now we're going to do it graphically. So here's the first thing we're going to do. If you haven't reset your calculator in a while, you might want to do that, especially if somebody else was using it, if you're using one of the ones from the back of the room. We're going to change the mode. So I'm going to do second mem 712. So I'm going to reset this. And I'm going to hit the mode button. Jack, do you really need to say that much out loud? So I'm going to come down here. We almost always leave this in function mode, but we're going to change this to sequence mode. So we're going to come over here to the fourth one over here. It says SEQ, so we're going to do sequence. And we're going to hit enter. So you just highlight that. Once that's highlighted, your calculator is now in sequence mode. So now hit the Y equals button, and you're going to notice that it looks very, very different. It doesn't say Y1 and Y2. It has UN, it has UN min, and then it has VN and VN min, and stuff like that. Okay? We're only worried about this one right here. So let's just stay on U. Okay? All right. So this is why you need to know how to do this both ways. We're eventually going to make UN look like this right here. So this is what we want to make it look like. So we're going to grab the list menu, the second stat, and we're going to make this. So the first thing we're going to grab is second list, so second stat. We're going to go to math, and we want to find a sum. We want to find the sum of a sequence. So we're going to hit second stat. We're going to go to ops, and number 5 is sequence. Now, again, depending on your calculator may say, it may come up in the U equals menu, and you may have to type everything in with commas and all that sort of stuff, or it might come up right here. So that's why I wanted to show you both ways yesterday. So the expression is this right here. So we're going to type in 3, then a set of parentheses. The fraction is 2/5, and we raise that to the x. Now, I said x. Notice what it does when you hit an x.
N.
It has an n. So take a look at the variable button that you normally hit for x. It has an x, then a t, then a theta, then an n. That button functions differently depending on what mode you're in. We're in sequence mode, which is the fourth one, so it's going to hit an n. So let's come down here and let's tell it, yeah, the variable is n. So we're going to do an n right there. Okay? and we want to make this start at 1. We want to make it end at n. The step is going to be 1, and then we're going to paste it in there. Now, if you don't have an operating system that allows you to do it like that, when we paste it in here, it's going to look like this. So you literally, when we hit the sequence thing, it would put a comma, and then you can come in here, you can put the expression, comma, n, that tells it what the variable is. You're going to start at 1, you're going to go to n, and then you're going to count by 1. The step is going to be 1. So as long as when we paste it in here or you make the syntax and it ends up in there, doesn't matter either way, we're fine. So I'm going to hit paste. Is everybody okay with that? Okay, so I'm going to hit enter, and that's what it looks like. Now, if you take the time to arrow back through here, what I have on here is exactly what I've got right there. Okay? All right, now we're going to go to the window. So if you hit the window button, you'll notice that it looks different. It doesn't just have an X-min and an X-max. It also has an N-min. Okay? Now, we said in the problem up here, it said, find the first 20 partial sums. So the cool thing about this is you can control the parameters for n. So we want to start at 1, and we want to allow it to go up to 20. So hit 20. If you want some extra space, you could put 50 in there or something like that. Don't worry about the plot start or the plot step. Hannah, can you pull the door shut for me? Okay. Because n, or the n's kind of the same as the x's, these are going to be the partial sums. So we don't need to count in the negative very much. So we're going to change the x. So we're going to change the x-min. We're going to change that to -1. We want to have space for 20 partial sums, so we're going to put 20 in there. The x scale, we're okay if that goes by 1. Now, listen carefully. The problems that we were doing, all of our partial sums were positive. Okay? And we think that the answer, if we continued this process, we think the answer is going to be 2. All of those are positive. So there's probably not a need for a bunch of negative y's. But depending on the answers that you get or your conjecture with the partial sums in, partial sums could be negative, so we might need to have some negative y's. So we're going to go from a y min of 0 to a y max of 5. Okay, everybody got it? Okay, hit graph. So in sequence mode, you'll notice if you were to hit y equals again, if you hit y equals, you'll notice that over here where it tells you what the way it's going to graph, there are 3 dots right there. So it's just going to do dots. It's not going to connect them because this is just a sequence. So if I hit graph again, here are the partial sums. And if you hit trace, the very first one is 1.2. Isn't that the one we got?
Yeah.
The next one is 1.68. The next one is 1.87. Do you see why we changed them to decimals and rounded? The next one should be 1.95 if I remember correctly, but it's got some decimal accuracy here. And then we keep going. Now, would you arrow over until you get to the 20th one?
It is 2.
Okay.
The asymptote was broken.
Okay. Now, I think you said it pretty well. You said it's just kind of come up here and get really, really close to 2. It's going to behave kind of exponentially. Okay? That's kind of what's going on here. Not exactly, but kind of. Okay? The calculator says it's 2.
The calculator's not wrong.
Is it 2?
No.
You said
Really,
that
really,
if we
really
put it in the
important
calculator
Mhm.
right, it'll come out with the right answer.
I did
And
say
I'm pretty
that.
sure we put it in right.
Okay.
So if that's right, then it gets to 2.
Okay. All right. Let's check. There's a couple ways we can check. So does everybody understand the process? Let's finish the problem before we do a little bit of checking. Okay. It says graph the first 20 partial sums. We're going to do a whole bunch of dots. Whoops. Need to change colors here. We're going to do a whole bunch of dots. Is our conjecture confirmed? Whoops. Wrong one.
Yes. No.
Okay. Yes, we think it's 2. Okay. We think it's 2. Okay. All right. Okay, a couple different ways to do this. Would you hit second quit? Hit alpha, and then would you hit the number 1? Okay.
Wait, what?
So, the calculator, last time we had this on the graphing screen and we had it in trace mode, the calculator said y was equal to 2, correct? So we went to the home screen and we just said, hey, calculator, will you show us what y is? And now the calculator says it's 1.999, whole bunch of 9s and then a 78 at the end. So when the calculator displayed a 2, was it actually 2?
No.
Calculator rounded. Did the calculator have stored in there, did it have the decimal accuracy for where we were?
Yeah.
It did, and it's not quite 2. You can check it there, and then you can check it in one other place. Would you hit second graph? That'll show you the table. Now, it doesn't take very long to get down here,
Yes, it does.
and at 12, it turns into a 2. Luke, stay after class. It doesn't take very long for it to turn into a 2. Okay? It turned into a 2 in the table when we got to 12. When we were doing trace mode, it didn't turn into it till we got to 20. If you have something like this that happens, especially when you're on the table, if you hop over here, so just hop over to the second column where the y's are, it'll tell you that it's actually this number. So if you go down to the 20th partial sum, it'll agree with what we had on the home screen when we did that before. Okay, everybody good? Okay, any questions? Okay, let's come back here and let's do this one. So I'm going to hit second quit. I'm going to come back to the home screen and we want to do this. We want to find the first 5 partial sums for this. So I'm going to blow this up just a little bit. Oh, I forgot. Okay, would you put some stars by these two? Okay, if we look at it graphically and numerically, it makes it relatively easy to kind of see what's happening if we let this go on forever. Are we going to get to an answer, or the answer is going to increase without bound, go to positive infinity, decrease without bound is the way we say that, go to negative infinity. But here's the big point. You cannot just rely on what we did graphically and numerically to say, yep, the answer on this is 2. You would want to do that algebraically, and we won't do that in this particular course. Okay? We'll see that another time. Okay, so we're going to take a look at this next one. Any questions before we do this next one? Okay, all right, so let's find, and I'll recall this or build it from scratch. Actually, this one's not going to be too bad. So I'm going to hit math and 0. And we're going to do, notice I'm still in this mode, so it's going to use an n. So this is going to go from 1 to 5, because we're doing the first 5 partial sums. Negative 5n plus 4. What one did I just find? I found the 5th one. So this one is negative 55. I found the 5th partial sum. By changing that upper index, that upper limit, I'm going to do 4. So this is negative 34. I want the 3rd partial sum, so I'm going to do that 3, so that's a negative 18. Sum of the first 2 is negative 7. And it's probably not even worth the time doing this one on the calculator, because if you just plugged in a 1, you'd have a negative 5 plus 4. So shouldn't we get negative 1 out of this? Okay.
Yeah.
So here are the first 5 partial sums. If you add up one term, you get negative 1. If you add up the first 2 terms, you get negative 7. If you add up the first 3 terms, you get negative 18. First 4 terms, negative 34. And first 5 terms, you get negative 55. Okay. What's our guess if this process continued? What would the partial sums tend toward if this continued? Wilson's got his hand up. Jack's got his hand up. Anybody else? Keely? Wilson, what do you think?
The answers are gonna decrease without bound.
Decrease without bounds. So what would our like limit be?
Negative infinity.
Okay, so our guess is negative infinity. Okay? Now we're going to graph these partial sums and see if we've got that right. So we're going to go back to y equals. Now, once this syntax is in here, it's your choice. Okay? I kind of like taking this and coming through here and saying, you know what? I'm going to, and it's tough to see sometimes, I'm going to delete this until I get to the comma. Okay? Will that let me delete? Ooh, with that exponent, it won't let me delete. That's weird. There we go. So then I'm going to insert negative 5n plus 4. And then there's a comma. Variables n. Start at 1. Go to n and step by 1. So the last part should look exactly the same. It'll be an n, a 1, and an n. And then we just make sure that the formula looks the way it's supposed to. And if you want to clear it off and create it from scratch, that's totally okay. Yeah.
Would you need parentheses around the 4?
No, I don't think so, because this entire thing from the parentheses to the comma, that's the expression. That's the explicit formula, the nth term formula. Pretty good? Okay, raise your hand if you've got that in your calculator. Okay, perfect. Okay, I'm going to hit, let's see, wait a minute. If we're going to graph this, if I just hit graph, that doesn't look very good. Why? Keely? Yeah, because we need to, all those answers were negative. We need to see a bunch of negative y's. So we're going to come down here. We're going to go to window. We're okay with it starting at 1 and stopping at 20. The x's can start at negative 1 and go to 20. But the y min, we think this is going to get really small, right? So let's maybe, the y min, let's maybe make that, I don't know, maybe negative 1,000. Step by 100. Whoops, the max, we'll make the max 100 and we'll step by 100. And then we'll graph it. And if we hit trace, there's the first partial sum. Second partial sum matches up at negative 7. Third partial sum is negative 18, negative 34, negative 55. And our guess was that this just continues. So it started off at negative 1 and then just goes off like this. So is our conjecture that goes to negative infinity, is that confirmed?
Yes.
Answer there's yes. Yep, it's going to go to negative infinity. Okay. Everybody good? Mason.